Dr. Colwyn Headley. She is a postdoctoral scholar at Stanford University with expertise in exploring how cellular energy systems drive health, performance, and longevity. Dr. Headley is also a lecturer at the Geneva College of Longevity Science and sits on several scientific advisory boards, including Wonderfeel, Mitrix, and We Hear You.
Thank you for the opportunity to come back to the Buck Longevity Summit. And so last year I was here and I talked about, well, first I'll say, I've done my share of Forrest Gumping through science per se, and oxidative stress and radical biochemistry has remained one of the most consistent things in the process, and it's kind of led me to look at mitochondrial dysfunction. At Stanford, what I've been really interested in is sort of understanding how mitochondrial dysfunction and whether repair can have an impact on immune cardiovascular axis, specifically in the context of aging. And last year I talked a little bit about mitotransfer and how we could use it to reprogram, per se, T cells to better activation, cytokine production, et cetera, and that this has an in vivo impact in context of infections. So we showed in both influenza and tuberculosis. And then lately at Stanford, I've been expanding this to look at the cardiovascular perspective as well, to see if we can now just expand this from just T cells to using endothelial cells, vascular muscle cells, and et cetera. I do think this is a great strategy for health span and longevity, but I don't think it's the only thing that we can do to stay healthy. And so at Wonderfeel, in the capacity of like a scientific advisor, I've been helping them understand the impacts of the younger, how the younger supplement supports mitochondrial function. And so before I start talking about the supplement and the things that it contains, I'm going to try to explain, without becoming too technical, what OXPHOS is. And so I used to run track back in the day, ran everything from the 4x1 to the marathon. 4x1 is a 4-person relay. You know, you got a baton, you're passing it, 4 people. In context of mitochondria, the OXPHOS is a 4-by-electron relay. Right, you've got 4 complexes, and the goal is the fastest way the most efficient shuttling of the electron from the first to fourth complex is the most efficient way to produce ATP. And so if this is the analogy for OXPHOS, then dropping the baton is kind of like mitochondrial dysfunction. So stepping out your lane, sort of escape of electrons, the loss of momentum is like the loss of momentum potential, colliding with other runners is a propagation of cellular damage, and if you don't finish, you don't make any ATP, especially from mitochondria. Now, I don't want to diminish the role the mitochondria plays. It's not just a runner. Making ATP is just one of the many events, signaling events that it partakes in. So it's much more like a decathlete when you really think about it. So whether it is, regardless of what the event that you're doing on the track or as a mitochondria, it comes down to preparation. So preparation really becomes practice and fuel. So practice as an athlete means form and function. You go out to the track, you go out and you run your laps, et cetera. Or if it's football, you go play football. For the mitochondria, that kind of looks like its ability to fuse and fragment based off of metabolic cues or cellular cues in the cell. Its ability to degrade bad mitochondria, and its ability to also make better ones or replenish the ones that get degraded. Fuel, in terms of mitochondria, really looks at the things that get shuttled into OXPHOS and that fuels OXPHOS. So that's really, I'm calling these the macros per se, but glucose that goes to pyruvate, fatty acids, and amino acids. And the micros are really the antioxidants and sort of the cofactors like NAD and vitamins and minerals that support OXPHOS activity. And so another event I used to do was the marathon. So imagine you're at mile 23 and you're fighting for your life. Like you're dying, you're about to start crawling, and you run up on one of the hydration stations and you get like a scratch. And so the scratch will allow you to maybe make it to mile 25, and then you're gonna have to crawl again. But in a sense, the Wonder Younger Fuel formulation is kind of like electrolytes for the mitochondria, in that it helps supplement or support the bioenergetic activity that is occurring. And so the 5 compounds or molecules that are contained within the Wonderfuel formula is NMN, ergothioneine, vitamin D3, resveratrol and hydroxytyrosol. So NMN is a precursor of NAD, and it pretty much supports replenishing the pool of NAD both in the cytosol as well as in mitochondria. And to some extent, your mitochondria and your cells are kind of sweating more than necessary as you get older, and that means that your your pool of NAD is being depleted or consumed, and so NMN is a great way to sort of supplement that. The other 4 compounds or molecules, arginine, as well as vitamin D3, resveratrol, and hydroxytyrosol, have antioxidant activity, that being either through direct scavenging of free radicals or through the upregulation of enzymes that help to scavenge free radicals. And so, back to the track, what that means is depending on, in your whole body, it's a bunch of track meets going on. So whether it's in the brain, in the lungs, or the kidney, wherever, the bioenergetic demands and the rate at which these mitochondria are running differ. And so to really comprehend sort of the benefits of the supplementation, we've been trying to characterize from a systemic level, systemically how Wonderfield Younger is improving functionality in customers. And so the approach we've been using is sort of a customer reported outcomes. And so, for example, I use Wonderfield for 3 months, and I can voluntarily provide information as to whether, if it helped me regrow my leg. That's an exaggeration, but people have been voluntarily providing testaments as to the improvements they've seen after using Wonderfield Younger. And so our job has been to really take these testaments, these reports, and then go back into the lab and mechanistically evaluate them. So kind of the approach that Your Age talked about, sort of like taking consumer stuff and find out more. And so this was some recent stuff that we published from around 200 responses. And so some folks reported improvements in hair quality. Some people reported improvements in focus, mood, memory, sleep, skin and nail quality. Some folks reported improvements in joint pain, decrease in joint pain and increases in exercise tolerance, so you can run a little longer, as well as improving digestion and decreases in inflammation. And so as an example of what we've been doing, I'll take the inflammation per se. So in some of our preliminary results, what we've done is we can test out whether an individual component within the Youngerfield formula or all of them are having sort of like a synergistic impact on inflammation. And in this study we did, we took some human PBMCs, exposed them to LPS, or concurrently treated them with dexamethasone, which is a corticosteroid, as a control, with NMN by itself, arginine by itself, or the combination of arginine and NMN. And then we performed an ELISA looking at IL-6. Looks a little blurry. Because IL-6 is a well-characterized inflammatory cytokine. So what we see is, compared to dexamethasone, NMN and arginine individually do not have an impact on IL-6 production, but the synergistic dosing of arginine and NMN significantly reduces IL-6 cytokine levels, almost to the levels of the corticosteroid. So it's suggesting that there's some synergy between with using these molecules together. Now, moving forward, we're really interested in digging deeper into how the Wonderfield Younger supplementation might be improving either health span, longevity, but also specific disease indications. And so we're interested in partnerships to really start propel our preclinical studies. So one aspect is potentially looking at C. elegans research to explore organism level improvements in lifespan, but also, like I said, targeted disease indications based off of the customer reported outcomes. So things like arthritis, eczema, irritable bowel disease, and neurodegenerative conditions. So holla at me. Our chief medical officer, Andrew Salzman, Dr. Andrew Salzman, is the principal person that you'd be interacting with as far as collaborating and designing experiments to sort of matlock our way into which reported outcomes have scientific evidence behind them. And one study that we've been looking at particularly, and a reason we want to do these studies is not only to validate the supplements, but we also want to contribute to broader scientific community. So for example, with ergothioneine, it's well known to have antioxidant capacity by directly interacting with hydroxyl radicals, but also innervating NRF2 signaling cascades. But still, that does not fully recapitulate or explain how it's redox salvaging potential. And we suspect that it might be the same way that using the proper running shoes on a track is important for stability. Our ergothioneine might be acting as a chelator to support the electron transport chain complexes. And so we'd be really interested in further pursuing this with collaborators. We're also interested in partnering with longevity clinics and clinicians to really refine the regimen for our consumer-based reported outcomes, but also we're also aiming to identify specific health targets and personalized longevity strategies. And so our CEO and co-founder and CSO is also in the audience. So if you have questions, please ask them. If you have questions about mitochondria, or if you want to collaborate about mitochondria, don't be afraid to reach out. And with that, I'll take any questions. Good question. We're still trying to figure out, pinpoint the full plasma concentration of the compounds, but the concentrations used for these assays, I believe, was 5 micromolar, so not a lot. And it was around 1 million cells, 1 million PMCs.
I'm interested in knowing about the hydroxytyrosine in your formulation. Have you looked into changes in the hormone levels because it could act as a precursor for hormones? Have you looked into that aspect of it?
We have not, but I mean, I would love to talk to you more about that.
Hi, love your presentation. And also, I think the whole strategy of having their customers to report on themselves is very innovative and very meaningful. But I do have a quick note about the experiments on the IL-6 production. When you stimulate the cells with IL-6, you are expected to have an inflammatory response, and the cells should actually make IL-6 because it's under attack, right? So you actually wanted to have more release. So I don't think treating the compounds, making the cells making less is not actually a good thing. Is my point.
I mean, so yeah, if you stimulate a cell with LPS, it's gonna make pro-inflammatory cytokines. But the goal is not to necessarily say that it's completely eliminating. It's just to validate whether there is any truth in it dampening inflammation. And so specifically with aging, right, when you have exacerbated inflammation, this could be something that could be potentially beneficial.
Yeah, I can understand the point. I guess it's more like in the context. I feel like because you actually do want to have IL-6 for your immune system to mount a proper immune response. Without it, it's the way you're validating it kind of seems a bit contradicting, I guess. Yeah, but it's true. With aging, you definitely have more systematic IL-6, but it's not coming from LPS, for example. It's not coming from bacteria. It might actually be coming from mitochondrial debris and stuff, but
right. But
the way of validating is.
But the goal is just to see if it has an impact on inflammation. So not to say that a person's gonna have they're gonna have a bacterial infection, or we're gonna tell them to take.
Yeah, got it. Okay.
That's
All right, thank you.
Thank you.